It's that time again. Good morning, everyone. All three of you. Today is one of those days where I'm going to ask you a very important question. And I end up asking this of everybody at some point, sometimes multiple times a year, because it's good to reflect on this. And the question is this: why are you here? Now, there's a lot of ways to approach this. There's the, what am I doing at 3 a.m. staring into the refrigerator? There's, what are we doing on this planet? What's the purpose of life, the universe, and everything? There's a whole spectrum of answers to this. But I want to focus in on why are you here in this school, if not physically, at least enrolled in this school now. What is your purpose there? Are you going to end up, as Alfred says, a victim of life? Or are you going to be like Batman and make the effort to master the chaos that's sweeping our world? And I can all say there's a lot of chaos doing a lot of sweeping this year. Okay? But you're here to learn the tools and skills necessary to rise above that chaos, to master it, and take control of, if not death specifically, but of your life, honestly. You're here to gain control of your life, to go in a direction you want to do. Make those opportunities open so that you have the choice. And that all starts here and now, every day, with the first choice: are you going to do your work? Are you going to put forth the effort? Or are you going to succumb to the temptation to, I could do the homework, but you know, there's PlayStation right there, and that's so much more entertaining. Or, but my friends are all online, and they're chatting away and talking, and you know, it's distracting, and I'd rather just do that. You've got to make the decision now so that you have the opportunity to make those future decisions, saying, no, this is what I want to do with my life. And it starts here and now. Okay? Remind yourself, why are you here? What is that purpose? And are your actions guiding you towards achieving that purpose? That's what I ask you to consider. All right. So with that in mind, our purpose today is, in my opinion, fairly straightforward. We are continuing with polynomials. We kind of glossed over the classification of them. We'll pick up the terms as we go, right? We did some adding and subtracting. We did some multiplying of a monomial times a polynomial, and just distribute that guy across. And now we get to the much more fun, much more interesting polynomial times a polynomial. This is the big stuff, right? This is where it gets kind of cool. And ignore this FOIL nonsense, okay? It's great mnemonic in pre-algebra, but garbage for us now. Do not rely on that, okay? It is only going to trap you into being stuck in only being able to do binomials. Because as soon as you get a trinomial in there, FOIL is no longer any good. So you need a more consistent system. You need some tools that are going to work more often and apply to more general cases. And that's simply keeping track of your distribution. Now, if you're very visual, I recommend, let's see, do they have a thing there? Yeah. Thinking in terms of the algebra tiles, which does extend to polynomials of any size, as long as you're only multiplying 2 of them at once. Right? And you could set up a grid. So, for example, we have here n squared, we've got 6n, and we've got -2 times n plus 4. And this would be one method you could use to keep track of. Make sure you fill all the boxes, right? And then all you have to do is just add up all the boxes together. You'll combine like terms. This has the really unique trait that as long as you write these in standard form, as long as this starts at the highest power and decreases, and this starts at the highest power and still decreases, you'll find that the diagonals all match up in their like terms. It's kind of neat that way. Let's use a different color here. Right, n squared times n would be n cubed. 6n times n would be 6n squared, negative 2 times n, negative 2n. And then second row, n squared times 4 is 4n squared. 6n times 4, 6 times 4 is 24. And negative 2 times 4, negative 8. And you can see we've got the n squareds there on that diagonal, and just the n's on that diagonal. So this is a really useful tool if you have the space. Right? The only downside I would say to this one is it expands your workspace into 2 dimensions. Right? So if you're really crammed and you're trying to do this straight on notebook paper, you're going to have to go more line by line like this method. But I kind of like this better. I wish I was taught this earlier on, and that was my habit. Okay? So I'm presenting that to you as an option. Now the way I typically do these, again, mostly by habit, this is what I had to work with back in the day, is I use fancy underlining to track things. Right? And I will say, okay, the n squared gets distributed there. And I write that down in order. Do not, repeat, do not go through and just draw all the lines in to start with. That does you no good. Right? Better would be to draw the line, n squared times n. Write that down. N squared times 4. Write that down. 6n times n. Write that down. 6n times 4. Write that down. Okay? And use these arcs, to track what you've gone over already and what you haven't. Because now I can look, if I'm ever paused, if for whatever reason, especially working at home, I'm distracted by someone or something, squirrel! Oh wait, back to math. Where was I? Let's see, I did the n squareds, I did the 6, oh, negative 2, right. Now I can distribute the negative 2, write that down. Distribute to the 4, write that down. See what I mean? It's useful for tracking where you are in the problem. And that, honestly, is the most difficult part. Second most difficult is making sure you match up the negative signs. That's going to be probably your number one source of mistake, would be negative signs. But your number one source of confusion and sheer difficulty is just tracking and making sure, did I actually multiply all of the things? I didn't miss one of the combinations. Right? And so you multiply all those out. I would never write all this down like this. You can if you want. I wouldn't do that. I would not even have written it down like this. I would have gone straight to here. As I said, n squared times n, that's n cubed. Write that down. N squared times 4, write that down. That's where I would have gone to. Right. Thought process, yes. This line represents what you are doing. This has rewritten it out as, oh, here is what you will then do. You will take this and distribute it to each one, but you're never going to write that down. And then this is writing out every single multiplication. You're not going to do that. You guys can multiply in your heads at this point. Okay? And if you do find, oh, well, it's one of the more challenging, it's like 5/12 n squared times 7/16 n xyz. Okay, fine. Yeah, maybe write that one out. Right? Only when you have to. All right, and then it's combining like terms. And this is where I start getting fancy with my underlining. I wouldn't have color-coded them there. I would just written them down. And I'd be like, okay, Here's the n cubed. Do I see any other n cubes? No, 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 no. All right, that's the last one. Here's an n squared, and we'll go wiggles next. Here's another n squared. Do I see any other n squareds? Nope. We'll combine those. Okay, 4 plus 6, that makes 10 total n squareds, right? So they get the wiggles. And then, now stick with the color because you don't have colors. So then you come up with something, maybe I'll do a like bracket system on just the ends, okay? Or you can do the double underline, right? Or you can do double squiggles. That's a terrible squiggle, right? Something to help you keep track of so that you can look down and you can see in this row, I have marked off everything. I used all the terms. And I have appropriately combined each one with only its matching and all of its matching terms. Right? Again, keeping track of everything is the greatest challenge here. Each individual multiplication step is not going to be a problem for you at this point. And that's multiplying polynomials. There's no more else to it. Okay? You're going to practice doing that because you're going to end up with seeing these quite a bit. It's quite a frequent occurrence. There's some word problems in the book that kind of give you an idea, but we've already seen how you can very easily model real-world data with quadratics. We're seeing more examples of, well, there's also other things that a more complex polynomial might be in order. And then you gain complexity as you include factors. Okay? This is involved in the final result, the thing we're looking for. Oh, wait, oh, we also have to include this aspect of it. Oh, what about that thing? Well, that contributes and multiplies towards our final answer. And they're all represented there as typically as binomials. And so you start multiplying all the binomials, you get a great big polynomial. Yeah. All right? So that's where they come from. Any questions then at this point? No? All right. Then you have a worksheet on Google Classroom. It has many practice questions. I think they actually start off with monomial times some polynomials, and then you got some binomial times binomial, and then at the very end you start getting some binomials times trinomials. I don't know if there's a trie times a trie. I don't remember, but it doesn't get too crazy hairy. I didn't give you like a 6 one times a 6 one, okay? But there are several of them. Practice makes, well, it doesn't always make perfect. Practice makes faster. That part is true. And that's what we're going for here. Master this technique. Make it become second habit. Second habit, no, a habit, second nature. That's the phrase I wanted. And that'll do it for today.